Good afternoon, and thank you for joining us for our latest MarkLogic Vision event. This week, we're all going to be talking about metadata, how we can capture that metadata, how we can query that metadata, and the importance of that metadata to drive context, meaning, and insight to your data to make it machine interpretable. Joining us this week will be Jeremy Bentley and John Snelson. Jeremy will be discussing metadata from a business point of view, what it means to your business, how you can apply it, and what value it can add to your organization. And then John is one of the major architects behind the MarkLogic Optic API, and he will be discussing the technical features that you're able to use within the API and how you can access and query that data easily. So I'm going to hand over to Jeremy now. He's going to walk you through these features. Please do make sure to ask questions in the chat. We will have a Q&A at the end of the session. And so please feel free to ask any questions that you would like. I've put in the announcements there, you can see, to join our second session with John on Thursday of this week at the same time, 4 p.m. GMT. Okay, without further ado, I will hand you over to Jeremy.
Yeah, thank you very much. So my screen should be sharing. That's great. Well, appreciate the time everyone's giving us. It's a commitment, and I hope that this is insightful, informative, and helpful. We'll go through. It's planning to talk for about 45 minutes, and then we'll have time for question and answers. And you can use the chat for those. But I was thinking about when we were putting this together, I said, well, why is metadata suddenly getting such a strong interest from the market? Why, when it's been a little, backward for, the 50 years before this, where people have not really thought about their metadata, and when you've looked at it, it's been like an orphan. It's been left alone, unmaintained, and very passive. Why is the role of metadata becoming so vital in a modern data architecture? Very specifically, the sort of the real modern data architectures, which are much more business encompassing, data lakehouses, data meshes, data fabrics, semantic knowledge graphs. And every time you read something about one of those architectures, which are much more business friendly, much more to do with addressing the elimination of, or the effect of silos, the first thing everyone says is get your metadata in order. Because of course, once you start to need to weave data as a supply chain, start to see it as a flow, start to make it the dominant persona, it's metadata, or the data about the data, that allows you to orchestrate and move stuff along. So I have quite a hectic agenda. We'll have this is a part of a series, so a quick introduction and a recap of really the last session that we did, and you'll also hear at the end of this what we're going to do next in the next session. This one's much more business. The one that John Snelson's running is much more technical. Between the two, you'll get a great insight into why MarkLogic is leading the field in this. Give you a bit of background on myself. I'm the head of strategy at MarkLogic. Before that, I was the founder of a company called SmartLogic. Semaphore, the semantic metadata platform, which was a leader in many of the different quadrants, is now an integral part of the MarkLogic data platform. So we can talk about metadata. It's my favorite subject, if a little dull at dinner parties. But 5 minutes of that, then we'll look at the why metadata is data. In fact, it's valuable data. So it's no longer a poor cousin that is different. If you think about it, data is the operational way of seeing the world. This is the transactions we've done. This is the customer relationship we have. This is the compliance processes that we've submitted. But the metadata is everything that describes that data. It's everything you know about that data. So it is data. And it's not right that it should be separate from the data. And of course, until now, many companies say, well, what we'll get is an operational data system, and then we'll integrate, I don't know, a master data management system, or we'll go and buy ourselves a metadata management system, and we'll do some integration between those two, and everything will be hunky-dory. And then any of us who who know about integrations, and we all do because we've been leading an integration-centric architecture of our systems for the last 30 years, know that change is very difficult to achieve if you have an integration-centric approach. More integrations, the harder it is, the more brittle it is to actually effect rapid change. So metadata is coupled tightly with the data. So you have one place to go where everything you know about that data is as addressable as the data itself, is a real march towards data agility. And so the second session of this vision is all about the Optic API, which is, of course, the way you get to the data and everything you know about that data from a single query. But I'll let John explain all of that. After we've looked at the metadata as a valuable piece of data, I've got some business data initiatives. Trying to visualize how metadata looks is very hard. It's typically created as a blip on a server. It's managed in a database. So I've tried to have a visual way of seeing the different types of metadata that you've got, looking at the different business data initiatives that it addresses. And then I have a case study about data value. It's predictive analytics using knowledge graphs. Knowledge graphs are incredibly going to change the world over time because they're amazingly good at analytical data surfacing and handling a hypothesis. So what if this? How was that? If I had this? Any relationships between this and that? All that stuff. But we'll go through all of that, and then there's time for Q&A. So when we look at the focus of MarkLogic, we're all about simplifying complex data problems, solving complex data problems. We're changing the way the world works with and uses data. We're providing a single unified data platform that's unlocking data value. We're accelerating insightful decisions because that's what business requires. Rapid response to changing signals. Data is how you represent the signals because that is the fact, if you like. And we're securely delivering data agility. The last session, we introduced you to the ideas behind the MarkLogic data platform, the ability to connect all and any data, to create and interpret that data, and then consume that data through a number of different patterns. Today, the metadata really is the centerpiece of the create and interpret stage, because without the ability to know what that data is and what it's about and what it means, the ability to put data into context is very difficult. So when we look at that, we think of traditional data platforms. Most of them in the world can connect data, yes, particularly if you're multi-model, which is what MarkLogic is. You can connect any data, and then once you've got it, you can immediately use it, and then you can consume it. But the create and interpret is genuinely a new way of being able to manage the data because we're adding to it. We're, if necessary, going back to source records and creating the data out of the document of record. Or we're managing the meaning of the data across different silos. You know, I happen to be British, you can tell that from my accent. I talk about, I'm going to go and fill up the car with petrol. Somebody else writes, I want to go and fill it up with gas. Petrol and gas are the same. We suddenly need just a simple creation. We need to harmonize that so that when someone's looking for a document about petroleum products, we don't miss stuff. The simplest semantic example there, but we'll get into that later. So the focus is on the create and interpret today, and why that's good for business, why it increases data's value, and why it assists with data agility. We looked last time at the MarkLogic data platform. We talked about it being the combination of the multi-model database and the semantic AI. We talked about the consumption, but I think importantly, it's what are we actually consuming? Well, we're consuming data in context. So that the platform is creating data in context, but ultimately data is only as useful as it is when you use it. So we're consuming data put into context to its state, its use, its audience, and its intended audience. We are consuming, if you like, data that is of high quality, where there's been an extra create and interpret wrapped around that data to make sure that it is complete. It is of high quality, it is calibrated, all of which are metadata functions. We are completing the 360 view of the data. We call it data unity, but what we're ultimately saying is regardless of where the data came from, regardless of where it lies, we still need to see it all in one place, have our hands on it, and it needs to be harmonized so that we can actually make decisions based on all of the subject of that point of that interest at that point in time. We clearly have to do it all in a massively secure way, and of course that, again, interpreting and creating is very important. You can interpret the data and you can start to see the data through the lens of security and not rely on rather blunt instruments that we do today. And also threaded all the way through this data supply chain is data governance. So that's where we got to with the first session. And now we're going to move on to the second. So metadata. Why is what sort of issues from a business perspective is it required? I know that this presentation is going up onto the portal, so I'm not going to call them all out. You want to recap on this, the report is we're being recorded, you can always go back. But let's take a couple of examples. My data lake and our content stores are really accessible. It's not an unknown problem, but actually fixing it is really hard. Because once the data has come out of the warehouses and moved into a lake, and the lake hasn't had any governance over it, and the data hasn't got any descriptions around it, and it's come in from all these silos potentially without any kind of restoration back to high quality, right? We've made an investment that's not paying off. We'll actually start applying metadata to what you've got in your data lake, for example, and we'll clean it up. And metadata is, remember, just data about that data. So we can append the data, metadata, the aboutness to that data. We can start to clean up our lakes. Our contract reality does not line up with our CRM system data. Very strong case there, because contracts, which is what you reach for when you go and have a dispute with a supplier or a customer, are always documents. And no lawyer gets out the database and says, oh, I see that's what it says. They go back to the source record. So the moment the source record actually comes out of doing a piece of business, typically it's marked up by a human, usually in a low-cost center, usually to an SLA, and quite often the system data doesn't actually match up to the original contract. And we have so many examples of that, and we'll look at that. We can go forward, look at our customer service scripts that we get from our help desk could be useful. The trouble is they're in text form, and now we need to use the information in that. Either we have to listen to them and mark them up manually, or we can use AI to do the markup automatically. So many examples of that. But complex data problems are solved by addressing important data quality issues, and data quality issues are addressed by making sure the data has its meaning and its definitions and its understanding and its relationships with other data available at the point of use.
Hi, Jeremy. Just a point of order. Could you just hide the notification at the bottom?
No, I don't think I can, but I'll try.
It should say hide on the screen there.
Where?
So if you come out of a presenting view, in terms of the PowerPoint presenting view, if you click that hide notification there at the bottom.
Oh yeah, where's that?
It should be at the bottom of your screen, just above the toolbar.
It's on here. I think we'll just have to deal with them.
Okay, apologies for that. There we go. Go back into the presentation then.
Where am I? I've lost it now. There we go. So yeah, so you'll just have, hopefully no one's going to be rude to me today, and then if they are, I shall apologise to my audience. So what we're doing here is we were talking about some of the problems, but basically think of it, and this is it's not meant to be deep, but it is actually. When you're thinking, we're talking here with metadata, we're talking about things, right? And for the whole of the computer world before, we've been talking about strings. So things are ideas, concepts, and how those relationships relate to each other. And I'll come to some examples in a minute. but you end up with things and not strings. So Jeremy, that's my name, Jeremy. The computer doesn't know I'm a person. It just knows that I'm Jeremy. And if it needs to find for me in the search interface, find for me all Jeremys, it will go and look for the string Jeremy. It's not actually looking for the concept of Jeremy as a person who works at MarkLogic, and so in order to become fully rich as a piece of data, we need to equip the Jeremy with the definition of the concept of him in that case, and who he's related to. So the technical world borrowed the world from the Greeks. The Greeks saw semantics as a branch of linguistics concerned with the meaning and refers to the capture and communication of concepts and the relationships between them. And actually, we all use concepts to communicate an idea of how something is, right, which is real world, or how something should be, which is often called best practice. But organizations can communicate using concepts. We talk about profit. We talk about FATCA if we're in financial compliance. We talk about top secret if we're, we've got some documents to make sure they don't go away and get an escape. We talk about SKUs. These are all concepts, and organizations communicate with that. We do. We say, oh, pass me that, or we use acronyms. We use language and we as human beings understand what we mean by that. If we don't, we ask questions and say, well, what do you mean by that? Whereas to date, the computer's data process has never thought about things. It's thought about strings. And then it knows that this string sits in this column, and this column is called cust, so therefore it must be a customer. It doesn't mean that this other column in a different database, also called cust, is actually the same customer. In fact, there's no way of knowing whether it is. So you start to understand that it gets hard. The second part around semantics is that we're talking about relationships. Concepts are related, have relationships with other concepts. Data has relationships with other bits of data. But those relationships are profound, because organizations, we may communicate using concepts, but they really run on the relationships between the concepts. So in this example, profit is up due to lower fixed costs, right? It's a really rich statement which communicates meaning of, in this case, two semantic triples, right? And we can talk about that, or you can ask me questions about that, but I'm not going to talk too much about this, sort of the plumbing. James Jones has been promoted to SVP. So when we're talking about metadata, we're really just talking about the meaning of the data attached to the data itself. And sometimes I call it a backpack. You've got your data, you've got your way, what we've done, what business we've performed, and attached to every data element is this backpack filled with the meaning of what that data is. It could be a brand, it could be a marker, it could be whatever it is, but these meanings grow over time as the data moves through its data supply chain. So you attach more metadata, more meaning to the data as it gets richer, and you don't want to lose that meaning because it's incredibly output. So what's this semantic AI? Well, ultimately it's just applying semantics using machines, and of course its output is metadata. So where does the metadata come from? Well, we have sat for 30 to 40 years, and you can see my aged nature that I've been in the industry for about that long. But until recently, everyone thought about metadata as being passive, right? But it's not, right? And I'll give you some examples. But most of the time, and we've had projects where we've gone into, government websites, and the whole 400 million documents have all been marked up as local government. Why? Because the metadata, they didn't care about it. But it's no use to anybody when it's marked up in such a way, and it's no use to anyone because no one, apart from the whole of the Chinese population, can actually mark up the metadata to the degree necessary. You have to automate the metadata process if you're going to keep it up to date and applying value. So traditionally, it's been manual user input and then a bit of system-generated input. And that system-generated input typically has been primitives coming out of content management systems, primitives coming out of the relational database that the system has put on. So the last person to load a document into SharePoint, for example, might have been someone who was told, could you load our record into SharePoint? So then the primitive is it was written by the person who loaded it into SharePoint. It doesn't mean it was, it just means the last person who touched it. So there was very poor quality around metadata as was, even if it's system generated. And then lo and behold, technology improves. We get to almost complete no governance on the amount of compute power we can use. We've got a huge advance in artificial intelligence. We've got coming together of sort of three special technologies of the AI, the ability to do multi-model databases, and I won't exclude the open link data movement coming together. And actually, do you know what? The architectures that data requires, so the ones I mentioned, fabrics and knowledge graphs and lake houses, and they all require what we call active and augmented metadata. They also require semantic metadata, right? The passive metadata, at least it should be kept honest and real, but actually it's we'll see later, as a valuable asset. The valuable data is in the semantic metadata and in the active and augmented metadata. We'll talk about that in a minute. So a quick statement, which I've been surprised about for some time, that has taken so long, but finally everyone's actually getting it, which is that metadata is valuable data, right? So this picture is on the right. You've got a picture of a very simple multi-model example, a bit of graph, a bit of JSON, a bit of relational. You've got the ability to bring it all together in a multi-model way. And then we've now appending the metadata onto the operational data in all its glorious forms. So metadata is data. The second point, the second part of this vision series is that gold bar on the right in the middle of the screen, which is the API that allows one, and that's what John's going to talk about, which is the Optic API, which allows you to query data and everything you know about that data from a single source, so using a single query interface. It's really powerful, and it's revolutionary, but I'll let him talk about that. But I did want to show you why metadata is valuable data. And in fact, forward-thinking data strategies have to be metadata centric. I don't think there's a prime analyst who isn't thinking that now, who isn't writing that now, who isn't advising their customers that to get your metadata sorted out, because actually, if you want to surface critical information and make data valuable, usable, secure, and trusted, it's no longer okay to separate data from metadata. You need to couple it together, and that's what the MarkLogic Data Platform does. But all metadata is not created equal, right? We've talked about the passive, and if you want to think of one single word that sums all that up, doubling core, right? Very important if you're doing records management, but doesn't move. At rest, equally passive, but actually at least we're extending it with attributes to fit a certain specific use case. Things like protective markers, disposition dates. We're still back. We're looking very much at records management. Very important job. Very important to be able to go back, to your records and 5 years later pull it out and show it to a judge and all that stuff. So clearly, the passive and the at rest has an important role to play, but it's typically content only, not exclusively, but pretty much broad generalization. But now we start getting into the semantic metadata, and the value starts to increase. We can start to mark up and describe the meaning of our textual data, and textual data, of course, is in every data asset. It's not just documents and emails. It is special instructions in a payment record. It is the notes that a doctor writes about his or her patient. It is, right? So now we're starting to add, topics, products, teams, projects, brands. This descriptive meaning of the data element, not the document, but the actual piece of data, gets a semantic makeover. Active is what makes a big difference in data management, because we can make our data management processes intelligent and dynamic. We can use them for operational use. We can integrate business workflows, and as the data moves through its journey, and I'll give you an example. As an airplane moves from was not open for reservation, but a flight becomes open for reservation. So seat, let's call it seat 3C, starts off life as 3C seat. 3C is empty. The moment a booking is made and that seat is allocated by the airline, it needs a piece of metadata. We've now got PII sitting on that particular element, 3CC. Then a piece of, I don't know, someone writes in and says, oh, I'm going to need a wheelchair for my something. And now we've got PII and healthcare data sitting on 3CC. And then take that to the final, you see that metadata moves as fast as the data moves. And then the aeroplane gets parked in the hangar, it's taken off for maintenance, and then it gets sold again in 3 weeks' time. So now we start the process all over again. So you start to see why the metadata has to move and be as active as the data itself. And then we get to augmented, which is where we're using a lot of AI to synthesize and augment the metadata. And this is the very exciting part of it. It's exciting if you're in our field, but I wouldn't say it's yet mainstream, but clearly in data fabrics, it's becoming mainstream. We can talk about that maybe in another session. But we start to orchestrate data direction. We start to inform machine learning. We start to not burn carbon finding out things we already know about the data. If only we had it properly marked up. We can burn carbon to find out machine learning analytics about stuff we don't know, for example. And we can start to provide data inference. Examples of that, and I'll let you read, but no or low code intelligence bots that orchestrate, right, automatically the data for you. Data process automation is a very different concept to robotic process automation. Robotic process automation is exactly what it is. It's robotic. Data process automation is about that automation using data in context so that you can actually alter the processes based on the meaning of the data. And then you get active collaboration. These are 3 very simple examples of things to come. But the focus really for, I think, most business people is looking at the middle part of the spectrum, getting the semantic metadata sorted out, getting the active metadata working in order to drive, business helpful data architectures, such as a lakehouse, such as a knowledge graph, such as a data hub. Okay, so you've heard me talk a little bit about the markup process and metadata, and you may say, oh, Jeremy, this is a bit 101, but actually, when you think about it, I'm not sure everyone sees it. So forgive me if it's 101 for you, but it may not be for others. What we're looking at is a data quadrant, very simplistic, they always are. We're looking at, a data quadrant which has got unstructured data on the right, on the left, and structured data on the right. And of course, it's a spectrum. We don't have one type or another. There's always an intermix of the two, of there, and it's a spectrum. And we've got data that's external to the organization or internal. And of course, when we talk about external or internal, we don't actually mean that it's external to the organization only. It might just be external to the silo that where most of the data is, and it's got across a silo boundary. So it can be perceived more richly, but let's take it as simplistically. And of course, in the unstructured world, we've got content and portals, and there's loads of other things not mentioned there. And then we start looking at the metadata issues. For content, it's incomplete. Right now, most companies will have incomplete or non-existent metadata in their content. Incomplete, right? Incomplete means it's either of poor quality, it's not maintained. It was maintained when it was originally put in, but it has been maintained for the last 4 years, even though there's a use case that still needs access to the 4 years worth of data, for example. And non-existent is often what we find. And then if you look at the portals, the things that drive customer engagement, it's inconsistently different. So you might have 3 different portals for the same customer. They log on, they have different ways of seeing the data about themselves. The metadata is inconsistently different. So typically it's manually applied. Typically, we've talked about that. So the content management system is applying it via simples, system primitives. The portals are powered by search engines who get their metadata from the content management systems and their programmed index strategies that mean it's very brittle to fix. when you want to change the way you're surfacing information to your users, blah blah blah. So, it's a broken process, partly because it's system primitives, and partly because it's manual markup done by humans, and humans really genuinely are not good at marking up hundreds of thousands of documents to the right level of granularity, to the right level of quality. So there is a case for automation, I think. If you look at the data side and go, well, what's metadata got to do with data? Well, the reality is that databases and data services, those two, simplistic spectrums in my quadrant, have, normally, I'm sure there are people on here say, no, we've got excellent reference data quality. We never make a mistake. We're perfect at it. No, normally the databases have poor reference quality, right? We suffer from data quality issues. They're poorly maintained. We've got non-existent glossaries. We've got semantic terminology and nomenclature differences, which makes it very difficult to bring information across silos together. Metadata role has this place to play, provided it's properly applied, right? And then if you look at the data services, well, the metadata is consistently different, right? Depending on which data service you use, it's not going to come to some kind of standard across the whole lot. So you can't go to 15 different data services and bring all the information and all the data you need using a consistently common metadata standard. But reality is, if you have the ability to interpret and set out this knowledge in your knowledge graph, you can. And that, of course, is the role of metadata. So, okay, here's a guess. How much data is in a sentence? Well, this is actually 3 sentences if we want to be particular about it. And I'll tell you what this is. It's one of hundreds of thousands that come into pharmaceutical companies every week, millions a year for all, just huge amount of content. It's called a real world evidence report. And it talks about information received from the reporter. This is a report of a serious adverse event. So it's when drugs interact with each other. That the person who sees the interaction needs to tell their doctor, needs to tell the doctor, needs to tell the pharmaceutical company needs to tell the regulator. And it's a very regulated business, but it's very important because clearly people, if you've got the information, you can do research on it. So we got a 3-sentence piece of text. Comes in an email or gets messaged across, depending on who's got the brightest and best platform to do this. And really, you've got to turn it into data. Well, in this case, and there's more data in here than been shown marked up, you take Semaphore and the MarkLogic multi-model server, and you end up with that text turns into that high fidelity, high veracity data automatically. And if you really want to study it, and maybe when you come back to this recording you can, I'll point out that it's doing quite a lot of interpretation. The easy one to interpret is we are talking about a 73-year-old white female subject who experienced a 5-minute blackout. The interpretation, the first interpretation, is that medically is known as a Caucasian, and a blackout is actually known as a syncope. So the rest of us call them blackouts, doctors call them syncopes. So there's a lot of interpretation here, and there's a lot of, you could take it further. You can say, well, it says, the female subject experienced a 5-minute blackout while taking prior to bed. Actually, you wanted to go deeper and you were researching. We don't capture the prior to bed, we just say nightly. But actually, somebody else may say, oh, you know what? Prior to bed, maybe if we say it's 3 hours before, I don't know, 10 o'clock, between 7 and 10, and you can see they took the Nason at breakfast, so we can call that 8 to 10. Well, actually, maybe the research is interested in finding out maybe it's a poor reaction because it happens within a certain time of taking the two together. It's not here, this interpretation yet, but it's an equally valid metadata interpretation, which you can do again later, right? So you can start to see your data in a very different active framework. And it works for everything. It's any business domain. This happens to be an accident investigation report. It's a bit gory, but no one was hurt. But it does talk about the accelerator pedal sticking and the servo seal failing on the master brake cylinder at the same time. Police report the vehicles traveling at between 60 and 65 miles an hour. First responder states that the 2 occupants were badly shaken but unharmed. Thank goodness for that. It talks about the airbags. So what we're seeing here is artificial intelligence governed by human beings, which is why the semantics is so important, because it's business subject matter experts who are creating and governing the knowledge around which drives the AI, actually creating high quality, qualified data, which is then stored in the MarkLogic multi-model server in our example. Okay, so how much data is in a sentence? It's almost impossible to answer, because you can keep using those sentences through the eyes of different interpretations, and I'll show you. In this case, this one, you could say they only marked up the stuff they were interested in, which was what was the cause of the accelerator. But actually, later the airbag team might want to come along and not be interested in what the cause was. They just want to know how the airbags performed, and you would rewash this data through. You've got your information about the cause and the parts that failed, and the second wash through gives you your airbag information, which another team may want to see. And this is very important to identify what we mean by interpret the data. Different audiences have different interpretations. Okay, and one needs to be able to keep adding these interpretations to the data, to make the data, to interpret the data, and to bring on the data, right? And not to lose the value of the data by throwing it away, because you may want to see it through a completely different lens tomorrow that you hadn't even dreamed up before you went to bed last night. My next point is that the business data initiatives, and this is how I'm going to show you. I said I'd try and show you how we visualize all these different bits of metadata, and the only way I can do it is with form. But here are the sort of business data initiatives that we might see it playing into. Making data out of source records of truth, right? That's called fact extraction, data extraction. Migrating, auditing, securing data, managing records, locking down our information security based on the context of that information and its state and who's looking at it. And of course, we may have a different interpretation of that depending on who's looking at it. So having a blanket, information security policy rather than a very nuanced based on the knowledge of who that person looking at it is and where they're located and how much time has gone by. Very important. Making money out of our resources. So we might have a very large amount of data and we now need to start mining it for stuff that we didn't know about. We might need to provide customer 360. We might need to provide, integrated search across many, many different portals in a very complex search environment. Define, read, discover, recommend. We might need to actually sort out our catalogs and our master reference data. And we might just need to understand the meaning and context of that data at that point of use. So those are the sorts of data initiatives that metadata is really profoundly important for. And this is the sort of thing it looks like. So this is, I hope it works for you, but this is how we might visualize. So we've talked about passive, at-rest, semantic, right? Now I'm doing a bit of content migration. I need to go to my knowledge model. I need to say, I'm doing some content migration. I need the at-rest stuff. So I'm actually going to, rather than put the stuff that was there, I'm going to harmonize it against what I know my content types to be. I'm going to look inside the document and decide whether there is, when I'm doing my content migration, any security markers we need to apply. It could be export control, could be PII. In this case, is there a protective marker that I need to put on it? I need to identify the region because it might be talking in that document about with a factory that that was located 10 miles south of Buenos Aires, region, South America, or region, country, Argentina, etc. If we're doing security and data loss prevention, it's probably a mix of at-rest, active, and semantic. If we're doing contracts and records management, it's probably at-rest and semantic, right? And you can see, and these are the sorts of, it's difficult to get the paradigm so that one's brain can get the concept when we're talking about these concepts. So that's why I thought I'd visualize it. When we're doing workflow, we're going to need some semantic about which product. We're going to need some at-rest, which is public health report. The product, right, might be, it's talking about, the drug that the public health report mentions, and so we now know that we now got to move that down a particular route of process. And then we're doing contextual user experience and informed search. So now it's probably all semantic, so we can get everything harmonized across the role of the across the index of the universal index that MarkLogic has, or of the search engine if you have a different one. And then we lastly leave ourselves with knowledge graphs and investigative analytics. So the knowledge graph just trying to find my way. It's in the way, I think. Maybe this is what everyone was trying to say. There we go. So the knowledge graph is the case study that I wanted to share with you. I'm just looking at time. I think we're doing all right. We go very quickly. But it's an aging population. It's a study in metadata. It's preventative analytics in healthcare. It's really, the use case is not meant to be morbid. It's actually very exciting because it stops people from, it's all about that 1 in 3 people over 75 years will experience a fall. Research has shown, and an individual who's considered at risk if they're over 75 years of age and have at least 2 risk factors from the categories associated with falls, those are the risk factors. And it's, on the one hand, it's dangerous for the person who falls over, and on the other side of the coin is it's expensive for the healthcare provider who has to fix the broken hip as opposed to address the initial issue. So the whole study was about, can we predict and prevent people from falling over? We know what the risk factors are. We know that the risk factors are demographic. You might be housebound. You might be living alone. We know there are historical factors. You might have come out of an acute illness. You might have had a previous history of falling. We know that we might have physical deficits, reduced vision. The brain may have changed a bit. I mean, all of these things are parameters in what is ultimately a big intelligence gathering operation to do with predicting when someone might be at risk of falling over, as opposed to picking them up after they've fallen over and had to take them for 3 weeks or 3 months in hospital or worse. So, and of course, drugs have a big part to play in this use case, because the doctor may not know that the person lives in a three stories up and the lift is broken, but actually then changes the drugs to help them, and actually that is a part of the cause of the thing. So you can see the many dimensional complex data that there is here to be able to do it. So the challenge is, how can health providers identify the at-risk population? We know that it's a complex data problem. We know the information is siloed. How is it siloed? We know that we're talking about data across organizational boundaries. We're talking about different types of systems in different formats. We're talking about some data is relational, some is in semi-structured forms, some is in natural language, so notes and histories, right? We know that different people express the same concepts. This happens to be a healthcare example, so that's not hard to come up with it. I complained about my dizziness. They wrote down orthostatic hypotension. There is no way that unless you're a doctor, you would know what that meant, unless you've also seen your medical records before. But you start to see it's not just the fact that the data is in different places. It's actually the same thing is called something different. It's a very human condition. Semantics and metadata is all about harmonizing that sort of thing. So the process, we get back to what the MarkLogic data platform does. Process is connect all those different systems, play the data where it lies, right? And in this case, it's it's the nurses' records, and we'll go through that in a minute. But it's the social welfare records, it's the medical notes, it's the data history, the medical data history, it's the semi-structured stuff that comes out of doctors' practices, etc. But then once we've connected it, we need to consume it. That's the output. But what we have to do is model the risks. I've described to you the risks as a doctor would describe them, or as a nurse would describe them. We have to put them into a model so that the machine can understand them. In this case, there was a very good, a lot of public ontologies around to model the knowledge model that people use, and we changed it. We augmented it with a couple of extra concepts. We actually augmented it with the risk of falling over and the association between the drugs and the risk of falling. And it took us 2 days to model the risks, and it took us 1 day to create the conceptual relationships. So the knowledge model was ready to then automatically extract. Okay. So the knowledge model is capable of automatically creating, extracting, and classifying the metadata. And what does it produce? It produces triples. In this case, it could produce triples as XML. It could produce triples as we could produce facts as any other kind of format. But because we were using a knowledge graph, we chose to extract the triples as RDF triples. Okay. And then those triples are coupled with the real world data stored in the multi-logic multi-model graph database. And Sparkle, which is a new query language around graph, was used to extract and give the answer. So we built the conceptual relationships, we modeled indoor tripping hazards. We then said, well, okay, what are the conceptual relationships? Well, we've got indoor tripping hazards, outdoor tripping hazards, we've got some drugs, and we need to bring them all together as a model. So this is the semantic model. And we put the MarkLogic fact extraction, run that over the data, which is coming out of the social workers' notes and the visiting nurses' reports and the electronic health record. And we get a Sparkle query that says, who's at risk of falling? So the consumption of that data didn't start just with the list. It started with sending around the repairman, go and sort out some home improvements, flagging and alerting doctors when prescribing a new or additional drug, and providing a self-source service portal for their families to start reporting, some of the hazards. The results, which before they implemented Semaphore by MarkLogic, 28,000 care home residents, 13 per thousand a day was the fall rate, 1.3%. The nursing staff could get around 375 of those a day. After they'd implemented this, the rate of falls fell from 13 per thousand to 1.67 per thousand. So a serious reduction or improvement in their risk by reducing the falls to the business. It saved them 18 million in hospital fees that they potentially would have paid if they carried on with that rate. So by using Semaphore and Graph on disparate and assorted data and content, truths were unlocked that the organization had previously been unaware of. And it's hopefully a very good example of why you see the metadata is data. I mean, you can say, well, why are we making that distinction? I'm not making that distinction. The world sees it as a distinction. I don't think it is. We have created and interpreted data, and we've created high quality data. We've put it in a graph, we've queried it, and we've saved one company 18 million a year in hospital fees using 4 days of effort and a whole load of technology, the MarkLogic technology. So that brings me to a conclusion of my vision pitch. Hopefully it's given you a bit of some theory, a little bit of application, and a real use case. But ultimately, it is all about data agility. And so I would thank you for your time.
That's great, Jeremy. Thank you very much. I think there was a lot to go over there.
There's a lot there. I could do more. Keep going for hours.
Definitely. And like we said, there's a second event coming up where we're going to do a deep dive into how to access that metadata, not just the unstructured data or the graph data, but a combination of those with structured data as well via the Optic API. So look forward to that on Thursday at 4 p.m. You can sign up on the Bright Talk links that have come through for you today. There's a couple of questions I just wanted to catch on in the chat. First off, yes, this is recorded, so the full on-demand session will be available for you to watch at your leisure. So if you've missed the first half or whatever that might be, then feel free to catch that. Now we're looking at some questions that have come in from the chat, Jeremy. So I'm going to
I'm going to look at the chat.
Delightfully hand over to you for this, but let me just go for the first question. So, how is MarkLogic Semaphore trained by a human? Does it have a non-code interface for subject matter experts? Would you agree that 80% of the effort related to a digital use case typically represents the data preparation? And does MarkLogic and Semaphore, do the MarkLogic data platform reduce this effort? And if so, roughly how much do you think that reduces that effort?
Yeah, I mean, it's quite a lengthy. There's about three things to answer in that question. The first thing I would say is that data preparation, you play the data as it lies, right? We really don't want to have to spend time preparing data, right? So, and I'll try and answer how we do that. Firstly, yes, we have a no-code interface into the knowledge model, which is maintained by business users. So if we have an accounting use case that we need to go and provide metadata for, we want an accountant to do the work of describing that knowledge. We don't need a maths grad who doesn't understand accountancy trying to build an algorithm, right? What we do have is a whole load of maths grads who are building our artificial intelligence engine that listens to the subject matter expertise that has been put in a no-code way. So hopefully that answers that question. So we've got really smart mathematicians, really smart coders, really smart programmers. They understand a huge amount of AI. The second point is we talk about data preparation. We don't need it. Play it as it is. That is the source of record. We may need to mark it up. We may need to, by markup, I don't mean change. I mean add, right? We may need to look at the added bits, not at the existing bits. The second thing is we could throw a whole load of this wonderful mathematician AI stuff at the content as it is, and we can come up with suggestions, right, as to what we think as a machine there might be a correlation between this and that. There might be a relationship between this and that, for example. Where we draw the line, though, is allowing the machine to make the definitive decision that that is an accurate relationship between two concepts. So we throw a whole load of AI at the suggestion, the candidates, if you like, and the governance is a subject matter expert who says, "Look, no, absolutely, that's a right association. Thanks very much. I'll take that. I'll move it in. I'll move it in."
So we're bringing the data to the data experts quicker using that UI, and the data experts are the one governing that data.
The data experts, unfortunately, the data experts are the ones who are bringing the data as a candidate. The business subject matter expert is the person who is saying correct business concept, because otherwise you lose the quality, you lose the governance of the mind that knows the subject in favor of someone who thinks they know the subject because they've written an algorithm. And it's really important that it's a no-code approach to capturing subject matter expertise in the knowledge model. And then it's a really automated machine approach to implementing that model into real world data.
Yeah, that's great. Thanks very much. And so I got another question here: is how do you distinguish between structured data, fields, attributes, etc., and metadata? And he's then asked, is everything metadata?
No, I think it's fair to call metadata data about data. The word is, there's a lot of data in that little three-word triple, data about data. The real important point is the relationship, the aboutness. So metadata, whenever something is describing the data, you can call it metadata. It happens to be data about the data, but it's about. So that about is really rich because it describes all sorts of things. It describes what security marker I have on it. It could describe what process I'm in at that particular point of time, that state. It could describe my whether the person, maybe it could describe a topic. Let's say that topic is insurance, and let's say that topic is, I don't know, asbestos claims. It might describe somebody's ability to read information about asbestos claims in Britain when they happen to be sitting in the office in Toronto. So the aboutness is a massive interpretation, and all of that aboutness is metadata. It's data about data. But the data itself is the operational data. The about the data is if you like, the calibration and the definition of that data and what we know about that data.
Yeah. Okay. So there's another question here: is how would you envision browsing numerous different schema so as to select the most appropriate one for your consumption use case at hand? I'm trying to visualize.
ask your local MarkLogic account representative to show you semaphore. We have a very good visualization. Right? That's
Great.
the best thing
Yeah.
I can do to answer in
a short version.
Yeah, I can't demo it, but it's really cool.
Yeah. I mean, so, and just to touch on that, there's a couple of questions. Can you show the ontology? Can you visualize it?
Yes, you can.
We do
All of
have
them.
so we do have a demo of what we've talked about really today and what we're going to talk about on Thursday. We have a full demo of this at the end of the month, which my colleague David Carrot is going to deliver, which will touch on all the aspects. So from end to end, from discovering the metadata to applying it to the data, to then pulling that data out, to then visualizing that data using various different BI tools.
So just coming back to that last question, all I can say to you is I really would stress when Matthew, who's now head of product at MarkLogic, and I started and built Semaphore, we built it with business users in mind, right? The only way you can get really accurate business knowledge captured is to think about the user who knows the subject. And quite often they can be, chemists or accountants or lawyers or whatever. And so I promise you, when you say, can you visualize, can you see? You have to be able to have that. It's a no-code approach. So you really have to be able to see it, report on it, check it. It's like an end user app, but it's actually driving a massive piece of artificial intelligence in the background.
Yeah.
And everything has to be auditable, so you can see how it made its mind up. Because you're a business person, you want to know, can you trust this data? So you need not only do you want to put your information in, your knowledge in, you want to see the results and see how it came to understand it. How did it come to those results? And that was another emphasis on repeatability, auditable, transparency, and all that stuff. But have a look at it. It's cool. I mean, it fits so well within the data platform because it's it's now we're connecting. We've always been able to do that. We're now creating and interpreting, relatively new, and now we're consuming. Always been able to do that in a really brilliant way. So anyway, that's the end of my advert.
No worries. Well, like I say, we've already got an endorsement in the questions that come through. There's no question. They've just said your visualization tool is amazing. It's my favorite thing about the tool. So thank you for those kind words there. I think one last question. I'm sorry if we haven't got to everyone, but I'm just conscious of people's time. So one last question. Would you say Semaphore is MDM?
It can be. It depends what you mean by. I mean, genuinely, I would say it's definitely reference data, right? It's used massively for reference data.
Yeah.
Right. You see, the reason why I'd say this is if you get a semantic or metadata management, if you get the create and interpret, you see, I would say you don't need that job for life called MDM. So everyone's set out saying, well, what we got with these silos, what we need is a single source of truth. And then we can spend the next 25 years keeping ourselves employed, trying to come up with a single source of truth and keep up to date with it. And I just think that was the completely wrong way of looking at it. Semantically, interpret your data as is, create a semantic, if you like, semantic MDM layer that does it much more elegantly. You can keep your systems exactly as they are and just put this on top of everything. And we might want to use the data hub capabilities of the MarkLogic platform because it may be that you don't want to hit your big back-end system so much and all that stuff. We can have a long conversation about that. But I would say MDM it could be, but I think there's a better way to doing MDM than to waiting 25 years to get a result. And this is the way.
Yeah. Well, if you want to learn more about MDM, we actually had a past
I can talk about that too if you like, but I don't have time.
Like I said, we had a huge past event of MDM and what MarkLogic and Semaphore have been able to produce on that. So it's well worth looking at that series. It's available on our Bright Talk channel. I'm going to wrap up now.
If you contradicted anything in there, then they were right and I was wrong. So, but I don't believe I did.
No worries. If we haven't got time to around to answering your questions, we'll reach out and make sure we get those answers to you. Apologies, but like I said, I just want to be conscious of people's time. Please do join us on Thursday at 4 p.m. GMT, 11 a.m. ET for our deep dive into the MarkLogic API, the Optic API, with John Snelson. It's a fascinating presentation. I've seen it ahead of time. John does a great job of describing how multifaceted this API is, and what it means to be able to query that data easy, and get access to that. So please do check out that. Again, that demo at the end of the month on the 30th of November with David Carrott. Again, that's on our Bright Talk channel. Please have a look at that as well. That really does talk to what we've been talking today about. Jeremy, thank you very much for your time. As
Well,
always,
thank you to everybody who joined. I hope it was a useful use of an hour. I'm very conscious that you give it to us, and I hope you got something from it.
Very much so. So, just lastly, there is a link to the recording. It will be sent out probably straight after the event. It might be a little bit of a delay just to render the video, but you will get the on-demand version of that. So that'll be sent to you on email, and it will be available on our Bright Talk channel as well to view on demand. Thank you so much for everybody that joined us, for all of your questions. We look forward to seeing you on Thursday. So wherever you are in the world, good night, good afternoon, and good luck. Cheers. Thank you very much. Bye.